My name is Johannes and I'm a software developer. Some time ago, a colleague of me asked me why I use this Java class called optional. So I told him, and I thought to myself, Johannes, you should tell more people about this beautiful piece of code. Well, here we go. An optional is basically just a container for one single object. And that object can either be null or not null. Like in this instance, we have an optional with a cat inside. And there might be a cat, or there might be no cat, so it would be empty. So as you see, the cat, the Java class contained in the optional, is defined through a generic T. Why is this useful, you ask? Well, it helps to show intent. If you see an optional object anywhere in your code, it is clear that it might be empty. There might be something inside, or there might be nothing inside. Either way, it is easy to find out and handle it accordingly. And through this, it makes the code more readable, and that's what it's all about, isn't it? Here we have some code, which is also available in my repository that I link below. So we have a simple main where an input is being requested. So we might just request some input, right? In this case, it's just a random value. And it might return 1 or it might return null, which is valid because it's an integer object. So instead of calling some input, we call get possible empty input. And what that does is it wraps some input in an optional object. So that's one example of how to instantiate an optional by calling of nullable. So that means the object that you give into this method might be null or might not be null. Either way, an optional is created. So at this point, we request the optional and we get the optional integer returned. And what we can do here is, because we know it might be null, or it might be an empty optional. We can call or else, which is a method on the optional class. And if a value is present, this method returns the value. Otherwise, it returns the other value, which is given, in this case, 0. So what we have here is what we get here is the input, and this might be 1 or 0, but never null. That's just one example of how you can use an optional. All right, some quick comparison. We have here a main method which gives us some input and some other input. Some input is an integer and other input is an optional integer. So when we generate some input, it might return null or it might return 1, right? Like in the example from before. So some input might be null or it might be an integer, right? But in the other input, there's always an optional. So if we look at the generate other input, we find it generates either an optional empty, which is exactly what it says. It's just an empty optional instance, but it's not null, of course. Or it returns the value 1 wrapped in an optional. So at this point, it is not clear if it's empty or not, but it's clear that it's definitely some object, and it's clear to read for other developers that this might be empty. And that's the whole idea of the optional. Of course, you can still misuse the optional and just return null at this point, but that would be a very conscious decision from the developer to, instead of returning an optional, return null. And this wouldn't make a lot of sense, to be honest. There are lots of ways to initialize optional. My preferred way is off-nullable. That's most useful to me, at least, where you put either null inside or some value. Either way, it creates an optional instance and returns it. So this method does not throw an exception if you put null inside here. Another way is to say the optional off, which creates an optional with the given value, but you're not allowed to put null inside. So it throws a null pointer exception if the given value is null. And the last way I want to show here is the empty instantiator, which is pretty self-explanatory. It returns an empty optional instance. We can create optionals now. That's pretty cool, but we want to use them. So the simplest way is to simply get the content of the optional, which in this case is the integer. But if you call get and there is nothing inside, you get no such element exception, which you probably don't want to get. So you can first check if something is present. So that returns true if there is a value inside the optional. So what we can do is, if there is a value present, we get the value. Well, that's not really useful, but we go ahead with it. So we have our integer. But as you can see here, maybe we want to have an integer either way and just replace null with 0. So another way is we put this here. Maybe we do this, but that's not really nice and readable. Well, no, to be honest, this is readable, but it's a lot to read and it does not do a lot. So this does exactly the same thing, but it's more compact and it's also pretty easy to read, right? So get possible empty input, and if not, or else, this is 0. So input in integer in this case should always be the same. One thing, so this is pretty much the same as something I want to write here. So say this is integer 2, and we get some input this time. So this might be null. If this is, well, not null, then we decide to integer 2 is 0, no, 1. Some input, that would make sense, right? So these are pretty much the same. So if you want to use an optional like this, don't do it, because there is no real sense in wrapping the whole thing in an optional and then using it the exact same way as you might use a null. One thing I want to show is the if present. So we get the optional again and say if present. If present receives a consumer of the action. So we can call this, and if there is some value in the optional, So in this case, if we have the one inside, then we want to do something, maybe, yeah, this out. So yeah. So all we get from here is always 1 on the sysout, but never null or 0, of course. That's just one really useful method that I use a lot with optionals. In Java 9, they introduced the stream method for the optional clause. To show you this really quick, I created a burger class which contains the bun bottom, the meat, cheese and bun top. As you can see, there are 2 constructors, one with cheese and one without cheese. And at the getters, there is the cheese getter, which returns an optional because it's not sure if there is cheese on this burger or not. And as an example, I created 3 burgers. And they differ in the cheeses. So one is with soft cheese, one is entirely without cheese, and one is with Swiss cheese. I created a list of burgers with all these 3 burgers, and then I got all the cheeses from it, get cheese, and put it into a list as well. So we have a list with 3 items, 3 cheeses, 1 soft cheese, 1 optional, and 1 Swiss cheese. And with this optional stream method, we can get all the available cheeses. So all the cheeses without the optionals. So this list contains the soft cheese and the Swiss cheese, but no optional. And that's how you use the stream method. It sounds like fun, right? So if you are a child at heart like me, every time you learn a new feature or technique, you find use cases everywhere you look. So that's what I did. I used optionals as return values. I used them within methods. I used them as parameters. I sent them over networks. I persisted them in databases. It was wonderful. No, it wasn't. So there are a few problems when using optionals. The type of the contained object is defined through a generic T. In this case, it's Boolean, or in this case, integer. So these 2 methods with the same name get merged into one, and that's not possible because these are 2 different kinds of classes. So Java, the compiler brings a message that erasure of method is the same as the other method. So you can't compile this code, unfortunately. On the other hand, what you can do is something like this, where you put basically a necessary parameter, for example, and then you add an optional and maybe another optional, whatever you want, right? So we bring a second optional. So, and then you can work with these 2 optional parameters and this 1 necessary parameter, for example. All right, so that's problem number 1. Let's move on to problem number 2. There is no serialization for optional. Since optional was designed as a return value, the Java expert group decided to not put anything but the bare necessities into that class. So, no serialization. If you're interested in that topic, I put a link down in the description where you can read about the conversation. As conclusion, we can say that optionals can make your code more readable, but there are a few obstacles along the way. So, we are at the end of the video. Thanks for watching. I would really love some feedback of any kind, be it notes or questions or anything. Write it down in the comments, and I would be really grateful for anything in there. Thanks. Goodbye.